Good evening. My name is Jim Yardley, and I serve as one of the directors of the Columbia University Nano Center. And it's my pleasure to welcome you here this evening to hear Professor Smalley talk on our energy challenge. Just mention for you that the Columbia Nano Center is a research organization here at Columbia. It's sponsored by the New York Office of Science and Research and by the National Science Foundation. And what we really do is seek sort of fundamental understanding about how charges move in sort of nanoscale systems, very, very small systems. We create new materials and we sort of fabricate things on a small scale. And so programs like this are mostly people. So here's just a picture of some of the people who participate in some of the nanotechnology research here at Columbia. Now, our co-sponsor in this particular event is the Earth Institute. And so I'm going to have Roger Anderson from the Earth Institute introduce tonight's speaker.
It's a great honor to welcome Rick to the campus. On behalf of the Earth Institute, the Lamont Doherty Earth Observatory, and this rather informal group we have at Columbia called the Energy Forum, which is a collection of everyone in the university that we can find who has an interest in energy. Rick is a Nobel Prize winner for the discovery of the fullerene. You've got it in your program. It is a geodesic structure for carbon to go with graphite and diamonds. It's really quite a remarkable event. His center in Rice is extremely interesting to us because of the breadth of their research into how these nanotechnologies and materials can be used and applied to real-world problems. In particular, the chemistry of carbon. You can read this about the Bucky tubes that we see as a future breakthrough, one of the great miracles that I'm sure Rick will talk about in a few minutes. But what really interests us is that this molecular perfection has raised a passion in Rick that touches to us in the Energy Forum, and that is in how to energize the planet. And with that, I will give the podium over to Rick Smalley of Rice.
Thank you. This is certainly a grand forum to talk about what I've increasingly begun to believe is a grand challenge for us, the world's humanity. This talk has been evolving over the last year and a half as I've been on something of a personal journey looking into the energy issue and particularly picking on the aspect. I'm a physicist and a chemist. If I can't find the answer to this, at least in concept, with the people I talk to, the people that I could talk to. And with a Nobel Prize, you can get into most doors and you can have a conversation. If I can't find it, maybe there is no answer. So I've been on a quest for terawatts, and this is sort of like a report on that. But it's also a framing of the energy issue, the debate, that I've been trying to formulate and to test with audiences like this, where I hold one hand behind my back. It's my left hand. And I try to talk about the energy issue with my right hand. And I mean the left and right side of the political spectrum here. And what I'm looking for is to see whether or not there is a logical, true, compelling argument that would cause someone with their right hand to walk over to the wall and turn a switch and turn on what may be the greatest scientific program in the history of humanity to solve what I believe is the most important problem facing humanity, is the brute problem of generating energy at the magnitude that we will need this century for what could very well turn out to be 10 billion people on the planet. I believe that switch, that if you're a right-minded person, or a Republican, Texas, business, energy-wise person, is the same switch that you would flip with your left hand from almost a completely opposite viewpoint of caring about the environment, the rich-poor divide, conservation. I don't actually care who flips the switch, but I'm compelled that you need to flip the switch, and that's what this talk is about. That's what I believe is our energy challenge, and by our, I mean those of us living on the planet here, on our watch, to solve this problem. So let me just jump to the chase. Here's my point. I believe that we will all agree, I hope after this talk, that if you had to pick one problem facing humanity today that's more important than any other single problem, it is energy. And the problem is that at minimum, by mid-century, we need to find some way of generating an incredible amount of energy, 10 terawatts in a sustained fashion, by some new source that we don't know what it is right today. And for worldwide prosperity and peace, it has to be cheap. And I've looked for a year and a half, using every skill and access that I have, to see whether or not there is the basis that will allow us to go with an engineering program and implement this answer. And at least at this moment, I have not seen it. I do not think that we have the basic enabling science and discoveries that would allow us to go get rich again, to find for this century what oil was in the last century. Some vast energy source, cheap, that drives and enables the economic well-being of civilization on this planet. Since, if you believe that's true, and I think pretty much everybody I talk to in detail agrees, then in order to get there, there's somewhere between 1 and 10 miracles between us and that happy day. It's very unlikely we're going to have those miracles just happen over the next year. We need young people to enter this field of physical science and engineering in a way that they haven't since Sputnik. I believe that this mission of going out and finding the basis for energy prosperity for the world from many different lines of thinking is the sort of mission that can inspire the good efforts and the dedication of life from young kids as well as old in a way that perhaps Apollo did, in many ways better than Apollo, more sustained. It sounds corny, but I think it's just really true. For this particular problem, being a scientist, saving the world actually makes sense. I like this, and it resonates in the hearts of kids, and I think it's really true in this case. And in order to support, to sustain, to make that thing work, I believe we need a new major research program of our country, and no doubt coupled with other countries around the world, which will be more reminiscent of the Apollo program probably than any other single enterprise that we've undergone. So that's what I think this line of argument leads you to. Any big program like that means money, big money, not just 1 year, but sustained year in, year out. This program would be the objective, the stated explicit objective of this is to transform the world's largest industry, which is energy. If you add together all of oil and coal and gas and nuclear and electric, everything, that whole business enterprise, in aggregate, it's $3 trillion a year enterprise. By far the biggest enterprise of humankind. The second most important is agriculture. I mean, it used to be that agriculture was almost everything. Agriculture is a half of energy. All the defense, both in the U.S. and around the planet, it's only 0.7 trillion, it's about a fifth, sixth. Energy is the biggest enterprise of humankind. If you are going to transform it, and that's exactly what I'm talking about. I want to find the new oil, which does for this century what oil did in the last century. Money actually isn't a big problem here. And this illustrates how little a problem it is. If you contributed a nickel for every gallon of gasoline that you use in your car, every gallon of fuel oil that you use to heat your homes, every gallon of jet fuel, just stop there. Forget about coal and nuclear, just stop there. That would generate $10 billion a year, more than that. And that's just right now at the current level of use. $10 billion is not a lot of money these days. It's not enough to get rights to fly over Turkey. But $10 billion is enough to transform the funding of the physical sciences and engineering in this country, which is currently, if you're very liberal in your definition of the term, $5 billion a year is spent on the physical sciences and engineering in the U.S. Nearly $30 billion on the NIH. $5 billion on the physical science. And of that $5 billion, the part that's really involved in frontier research that has any prayer of developing the sort of miraculous breakthroughs that are necessary to hack this problem is a small fraction of that. $10 billion a year, year in, year out, just because you donate a nickel, I don't call it a tax, it's a contribution, would transform this. Money isn't a problem. Commitment and the sense of mission of kids to get into it, like we did with Apollo. That's what's necessary. It's interesting. This is the physical science and engineering. It's the essence of what makes business be what it is. So we wouldn't even have Microsoft if it weren't for Intel and microelectronics industry to do that. That's whole entity was created and is sustained and continues on Moore's Law because of guys and girls who make stuff and make stuff work. The physical sciences and engineering. At worst, if we push this, if you gave me the nickel for every gallon of gasoline, you did this year in, year out, and we get this inspirational call, I think it'll be inspiration to the kids and ourselves to get into this mission. The worst thing that'll happen is after 10 years, we'll have a cornucopia of new technologies that will come out that will almost certainly be the basis of many new industries. That's the worst that will happen. And we still will not have yet hacked the energy problem. At the end of 10 years, maybe at the end of 20 years, you still haven't hacked it, and it turns out that Mother Nature actually played a great trick on us. Oil was just the best thing you're ever going to get, and you used it up already. And there is no way in the universe to really be cheap and abundant and clean with energy at the magnitude we need for roughly 10 billion years. Maybe that's the trick that Mother Nature played on us, and 20 years from now, we're saying oil sure was a hard act to follow. At best, we actually discover the basis of this new oil, and we've now permitted it to happen, that the huge enterprise of worldwide energy creation, which has got to be tens to hundreds of trillions of dollars of invested capital, can be in the process, can start the process of transitioning to this new energy future, which is going to be dramatically different than what we had. You just can't, if I knew right now how to build a plant to do what we need, say it's going to produce a gigawatt of power, 1,000 megawatts, a typical power plant, and it uses some new technology. I don't know, maybe it's clean coal, or it's solar, or it's wind, I don't know. And I got all the funding together, and I built the plant, and tomorrow I turn it on. And the next day, I turn on another such plant. And the next day, another such plant. It will take me 27 years to get 10 terawatts of power. That's just a piece of the current energy thing. So I need to have this enabling technology, the enabling science, I like to say miracles. I need them to happen sometime over the next 10 to 20 years if we're ever going to get to where we need to by middle of the century. So that's it. That's my point. So let's go back to this one issue of, can we all agree that what the most important problem for humanity is? That would be quite an accomplishment. So here's the argument. And the way I've gotten this to this point is I have asked audiences, not quite as grand as this, but on the spur of the moment, not knowing I'm going to talk about energy, I put up basically this PowerPoint slide with the numbers 1 through 10 with blanks after them, and I've asked the audience, what do you think deserves to be on this list? So the question is cast with the world staring you in the face. So I want to know the problems for the world, for humanity worldwide, not just locally in New York City or in Texas. And I'm casting it at mid-century, so we're far enough away from the idiosyncrasies of our current political and economic realities, but not so far away that it's irrelevant, particularly for the energy issue, if you turn up the answer, since you need so many years to get into it, to develop the technology.